Geometric, the difference between geometric and arithmetic is that arithmetic had a common difference. Geometric has a common rate. Think of it as a multiplier. It could be multiplying by 6. It could be multiplying by -1/3. It could be multiplying by pi. I don't know. It's just a common multiplier. So it could be positive, it could be negative. This is where you see how signs oscillate by multiplying by -3, positive, negative, things like that. If things are, don't write it as division. Always write stuff as fractional. It is much cleaner that way. Okay, just so you. So if things are getting cut in half, say it's being multiplied by 1/2. It's, in the long run, you'll have to believe me that it's cleaner. That's all. All right. So quick formula, nothing crazy. When you're talking about these sequences, when I'm saying looking to divide, think of it in terms of working backwards. More like that. 2 divided by 1, 6 divided by 2, 24 divided by 6, 120 divided by 124. Is there a common factor moving forward? No. This one would be times 2, times 3, times 4, times 5, times 6. There's a pattern there, but it's not common. Excuse me. 81, 27, 27, 9, 9 to 3, 3 to 1. What's happening each time? Multiply, divide by 3, multiplying by 1/3. Okay, each consecutive term. So that's just another way of looking at it. There are still going to be ratios and whatnot that you're, like that first one, 1, 2, 6, 24, 120, you'll be able to figure out the patterns, but it's not going to be a geometric where these next, where we're going to deal with a geometric sequence or a geometric series. Neither of those two formulas will work for that type. Okay, just like I said, it's a lot of formula stuff, so we should be, I guess, just kind of happy about that. So you get this, the nth term of geometric sequence. So geometric looks like a sub n is first term to your rate to the n minus 1. First term times your rate to the n minus 1. So the rule for the geometric sequence that when 81, 27, 9, 3, 1, blah, 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 is nothing more than figuring out what your rate is. Your first term is 81. Your rate is 1/3. So your rule, first term times your rate to the n minus 1. And that's it.
Wait, that's it?
You can learn. Yeah, that's all the formula is to it. That's it.
Wait, like that's.
That's how you figured it out.
That's all it is, guys.
That's all. Shut up.
Wait, like we don't do
All
anything else
right,
with
shut up.
That's all.
You'll miss me and my quirkiness.
I'm
You
really
move on.
confused. Like, that's
You
as
walk
hard
by
as
my
it gets.
classroom and go,
Will I actually?
"Miss Murphy,
I'm still waiting.
your class was funny."
Wait, that's as hard as it gets.
No,
Or is that like the only problem you have on there?
Ready. That's all it is.
There's no way that's all it is.
Okay. All right. Screw all of you. And
Braden
I-
started.
yeah, as I said something nice about the kid for a change, he turns on me.
All of a sudden
I
I
know.
hear saying, that's all it is. Then look what he did. Set the whole room.
It's just funny because like I missed so much school, so I watched so many of like your videos. It's just a lot easier to tell you like how many times you.
Yes, I get it. Just like, you know, Mr. Fontana is a clapper. He claps when he teaches. I just stand around and put my foot up against the wall right here. And
Part of the paint where it's like.
do you see where all the paint is worn off right here?
Yep.
You know why? Because we do this all day.
Maybe your shoes are dirty.
Your face is dirty.
That was actually a good joke. I'm so proud of you.
What's the first term?
You didn't even hesitate.
Negative
It's just
8.
like, boom.
What's the rate?
3 halves.
3 halves.
3 halves, good.
I like it.
And then what would you do if you had to figure out, sorry, what would you have to do then to find out the 8th term?
You say my name a lot.
You
Like,
just put 8 in for n and press
Oh no.
buttons.
Uh-oh. You say oh.
Okay, so let's make this crazy.
Oh, I told you.
You're laughing
Graphing is silly. No reason. You know why? You have a button. Apparently there's 5/4 in here somewhere. So one term of the geometric sequence is the 3rd term, and that equals 5. The common ratio is 2. Write the rule. Well, just like we did yesterday, or 2 days ago, when you have these types of formulas, you basically have your nth rule, first term rate. The n values are kind of always going to be the same, so theoretically, if you want to get into it, there's only 3 possible variables, which means I can give you 2 of them, find the 3rd, and rewrite. Just like we did with slope-intercept form. I mean, you've done this time and time and time again. So my suggestion, write the rule, fill in what you know. 3rd term will be the first term, rate, to the 3 minus 1, but my rate is 2 squared. And my 3rd term is, what's 2 squared? 4. So how do you get that first term by itself?
How did I know?
You multiply by 78 and you wind up with 5/4 as your first term. And then just rewrite that. And that's all it is.
Oh, because this ends up being.
I thought he was serious. I was like, is that some other step? Like,
Okay. Just like we did with the arithmetic stuff, you can be given a difference and a specific term in the sequence, and you just work backwards to solve the first term. We do the same thing with geometric, and that's the algebra that gets thrown in here, where you're just kind of resubstituting and solving a literal equation. So, the goofiness of this really does become, remember how we had systems of equations with arithmetic stuff? We still have systems of equations with this. You just got to be careful with your exponents. So you have some exponent rule stuff to worry about. Also, sometimes we have to solve for an exponent. And when you have to solve for an exponent, what do you use to get the exponent to drop? Yes, magic. I hear it grows on trees. That's a hint. Logs. Just get it. It grows on trees. Kathleen, I disappoint you. I'm sorry. She just rolled her eyes and give herself up.
I'm not very good at logs.
They're big, they're heavy, they're wood. For example, here's 2 terms in a sequence. One term is 45. It's the 2nd term. The other one is the 5th term, and it's negative 12/15. That was what? So write out the rule twice and work through it. You'll write them out independently of one another, and we're going to do some substitution steps via systems of equations to isolate out your term. The 2nd term is 45, which means that's the first term to the rate of the 2 minus 1. So 45 is the first term times the rate to the first power. Okay. The fifth term is negative 1215, which is the first term rate to the 5 minus 1. So that's negative 1215 is my first term to the rate to the 4th. Now you just want to make a decision. Do you want to, which one do you want to isolate? I'll give you a hint.
45 one.
Which one doesn't have an exponent? I'm talking variables. The first term. You know that steak sauce that nobody really likes?
Oh,
Hey,
A1's
Who doesn't like A1?
A1's delicious. Like you're spicy.
Would you like not like cheese or something? You like something that you don't like?
Yeah, I think
Is
he
that
said
it?
that he doesn't
Yeah.
like cheese.
I don't
Like,
like
he gets-
cheese.
Who like?
Like he
Why don't
takes.
you like cheese?
Didn't you say take cheese off pizza or
If
something? like that?
pizza's too cheesy, I take the cheese off.
Oh, that's messed
Oh.
up.
Pizzas can't be cheesy.
Okay, all right. I get it. I get it. I get it. I'm a card-carrying communist. Would you like to see the card?
Yes.
Like you're actually gonna pull it out.
Emma, what is communism? Do you even know what communism is?
Leave me a little Twitter.
Sorry.
So let's try not to get political in our discussion of math here. Just trying to keep a straight face on that one too. Again, all I'm doing is isolating the first term. You're always going to isolate the first term because it's never going to have an exponent to it. You know what?
Do you know what communism is?
So substitute that one back over. You'll have negative 1215 is going to be 45 over r to the first times r to the fourth, which means you have an exponent rule part. R to the fourth, r to the first, who wins? So what's 4 minus 1?
What?
So negative 1215 divided by 45 is negative 27. Oh no, I don't know how to take a cube root. Or can I take a cube root of a negative? It's how much? It's negative 3. Do you guys remember what button to press to get a cube root? What was it? Math
Power,
4 of your answer.
Yeah.
Okay.
Is it okay if I just do my answer for the power?
What happens if you?
So that gives me a rate of negative 3. And if I know my rate's negative 3, that means my first term is?
Wait, is that supposed to be an R right there, Mr. Murphy?
Yes, it is.
No. I mean up there next to the 45s.
Here,
No, down one. Right there. Right there. What's that?
and an R.
R?
It's off to the side, whatever. So it gives you a first term of negative 15. So you have a first term of negative 15, a rate of negative 3, your rule, negative 15 times the rate, negative 3 to the n minus 1. Make sure you throw your rate in parentheses. It just kind of distinguishes itself a little bit. So that's about as goofy as that gets.
Okay, that's fine.
Yeah, right. Series. Trap, you're gonna love this. No, you won't. Series.
Oh no.
It's not. It's an nth rule problem. Oh, it's not. Oh, this was hard.
Is this the last?
You said it's
Is
not.
this the last unit of the year?
No, we have probability statistics.
Oh,
That's fun.
We're gonna play some cards.
Blackjack.
games.
Yeah.
Emma, I said just fun and consistent.
I thought you said this doesn't look like it. All right. So the sum of a geometric series, it looks a little bit weirder. One of the things that you will notice, just like we did with arithmetic, remember how we said find the sum, or how many you have to add together to get a specific number, and you can work backwards and do factoring? Here, if you notice you notice how your n value is an exponent to the rate. That means when we do that, we're going to have to work backwards to solve for an exponent. And when we work backwards to solve for an exponent, you have to use a logarithm to undo the exponent. But it's just a button. Okay. So, let me show you an example. Geometric series, 1, 5, 25, 125, 625, and so on and so on and so on. Let's find the sum of the first 10 terms. Doing the exact same thing. We still want to, we probably have, well, let's see, we have a first term of 1, a common rate of 5. So the sum of 10 of them is first term 1. Actually, we write this all out real quick. So the sum of 10 of them will be first term 1 minus our rate to the 10th over 1 minus my rate. Throw it in the calculator. Please be careful in how you type it. Use the fraction bar. It's your friend.
It's got a really big number.
Well, look what's happening. You're taking 10 numbers in a sequence that each consecutive number is being multiplied by 5.
Oh, and then, okay.
So yeah, it's going to be a big
But then
number.
you divide it by 4.
Ah! But put it all together. Just 1 parentheses alpha y equals 1 minus 5 to the 10th
Oh, this
over 1 minus 5. Throw the calculator just like that.
Yeah, that's what I got.
Big number. Whatever. It's a big number. Okay.
2,441,000. It was every day.
All right. Going backwards is what's weird. Find n such that how many do you have to add together to get 3906? Well, write out the formula to start. We know we want to find 3,906 of them. First term, 1 minus 5 to the n over 1 minus 5. This one isn't so crazy because of the fact that your first term is 1. Okay? If it wasn't, I would divide by the first term right away, just to move that out of the way. Okay? Now, in this parentheses part, well, actually, let me write this step out real quick. I'm going to divide by my first term, and I'm going to get 3906 is 1 minus 5 to the n over negative 4. Find the sum that adds up to equal 3906. It's basically, it's asking, bless you, how many do you have to add up to get to 3906?
Oh, okay.
So now what do I do? Multiply by the negative 4. Negative 15,624.
Oh.
You were on the phone, I think, at that time. Add 5 to the end. Add 15,624. Switch sides to them. Yeah. Now this becomes a log-based problem.
Like Wait, isn't that 4 on this road?
No,
1 minus.
like, it's 1 minus 5 to the end. So I added 5 to the end to the right, and I added the 15, 6, 24 back to the other side. So now, in order to get an exponent to drop, we have to remember about our log base rules. Log base b of b to the n equals n. Sir,
Please go, please.
1 1000.
What did you do with the negative 4?
I multiplied.
Yeah, but when isn't it?
I just multiplied here by -4 and here by -4, and that's why I got that.
But don't you have to multiply like the 1 by -4 also?
No, it's 1 minus 5 to the end all over -4.
Right.
This here is this here.
Yeah, right to left of that is the 1 over 1.
Yeah, what's,
Don't you need to multiply?
no, I've already moved it. I moved that first. Always move your first term first. Because what's 3906 divided by 1? 3906, so you don't have to worry about it. You don't have to do that. You move that first and then you're fine. Okay? Think of it this way. Think of it this way. If it's track, isn't this the same thing as saying, oh, I'm going to divide by 3 first, and then multiply by 4? That's all I'm doing. It just looks weird because there was a 1. To get this to drop, he's got to take a log base 5 on both sides. How many of those do you have? 5 to what power is 15, 6, 25? Remember what button that was? Was it like alpha window 5 or something?
Yeah, it's off.
There are 6 of them. I know.
What means it took 6 turns to get to this one?
1 plus 5 plus 25 plus 125 plus 625 plus something else is that. Things add up quickly. I get it. I know. You're moaning. Oh, boo. Oh, in the book, this is great. There's a cell phone picture, and she has a cell phone that's about the size of my coffee mug, and it had an antenna that you had to pull out of it. Yes, it's hard to believe, cell phones were this big. Did you know that?
Yes.
Did you know they also came in bags that were probably bigger than your Chromebook bags?
Yes.
Yes.
Yes, they were. We had one. We thought we were really cool. We had a cord.
You had a cord full in your car,
Yeah.
so it's like they use it to call your car, but like you were in the car.
Yes, the car had its own phone number.
So if you wanted to go call someone who only had a car, you called in the car and hoped
Right.
that they were.
Or you know, some people had pagers, and then you could call someone on a pager and give them their phone number, and then that person would call you back and say, "Did you beat me?" And then then we learned how to do alphanumerical stuff by spelling words with numbers on a phone pad, but it was still showing up as letters. So people had to decipher what you were spelling by knowing what the letters were in relation to the keypad.
A couple months ago, Matt taught me how to spell words. Yeah, spell words with
Yeah.
zeros and ones.
Oh, okay.
Yeah. He's been teaching
Well, if you use 0, oh, you're just using code then.
Yeah.
I'm thinking Morse code because that's not.
No.
Yeah. You-
I remember. It was.
Yeah, it's F. Yeah, it's GHI.
Brayden and Tanner. What? And then that one had 4.
You guys are tight.
Yep. Tanner.
Do those both have 4?
I think so, yeah. And then they
So-
had like this star and the other one.
Yes, we would actually sit there and type numbers to people that had pagers, and you just read it and you have to figure out what are they selling, what are they trying to
This
tell
is
you.
my line.
What do they say?
So yeah.
Doesn't like a page usually mean like they, you know what I'm saying?